Hello class, so in this video we're going to be talking about geometric series. So this isn't a convergence test, but there is convergence related to it. So we'll just kind of talk about that. And yeah, so here is a geometric series. Basically you have some number times something raised to the n power. So the power only applies to the r. Make sure you understand that. And essentially if r is between -1 and 1, so absolute value of r is less than 1, then the thing will converge and we get the sum equals this. And if r is greater than or equal to 1, then the thing is going to diverge. So let's talk about why that is a little bit. So scrolling down. Okay, so if r is greater than 1, let's apply the divergence test. Limit as n approaches infinity of ar to the n, just going to be a times the limit as n approaches infinity of something greater than 1 to the n. So if you raise a number bigger than 1 to the n power, that's just going to get bigger and bigger and bigger as n approaches infinity. So there's going to be infinite, therefore by divergence test, s diverges. Well, how about if r equals 1? Then we just have the limit as a. The limit as n approaches infinity of a, because r to the n, if r is 1, then we have 1 to the n power, so just a equals a, but that's also not 0. Therefore, also by divergence test, s diverges. How about less than 1? So similar thing with number 1 over here, except for one little change. R is less than 1. So when you have something less than 1, or between -1 and 1, being raised to a power, that just gets smaller and smaller and smaller. So that approaches 0. Therefore, this may converge. By the theorem, we know that it does. We're not going to prove that here, but it does. So when do you use this? Well, if you have a geometric sequence, obviously, in there. Or if you can change the sequence inside to become geometric, then you can definitely use it. Alright, so let's see if these things converge, and if so, then let's determine their sums. Okay, so at first this might be a little bit hard to do, but with a bit of algebraic manipulation, this makes everything we can make everything a lot more manageable. You should be able to see that we can do this. And therefore break this into two different summations. With powers like that. So this actually makes things really easy, because we can tell that we have two geometric series now, and both their common ratios are less than 1. Therefore, we can write two different sums with them. So a is 1 in this case, over 1 minus r, so 2 over 5, plus 1 over 1 minus 3 over 5. Let's see, what's that going to be? That's going to be 1 over 3/5 plus 1 over 2/5. Okay, so do that all out. We get, let's see, 2/5 plus 3/5 all divided by 6 over 25. That's going to be interesting. So that's 1. So this is going to be, let's see, 25 over 6. All right. Now let's go on and look at this. So at first this might not look exactly like a geometric series, but we can make it into one. by some simple algebraic manipulations. Actually, wait, I think I meant for that to be n minus 1, not 4n minus 1, just to make things a bit easier so that we can illustrate the concept rather than focus on intense algebra. Yeah, let's do that. N equals 0, so that'll be this. So we can, so that's to the 4 to the negative 1 power, that's 1 over 4, so then that'll basically just be 4. Times 3 over 4 to the n power. Geometric series, r is less than 1, this thing converges, we can use the sum thing, so we get 4 divided by 1 minus 3/4. So that's 4 over 1/4, which equals 16. Alright, so geometric series, not too difficult to work with if you can recognize them. So work on recognizing them or manipulating them algebraically to be that. Okay, so that's it for this video, and hopefully it was helpful. See you in the next video.